Hello students, this is the third video on continuous functions. In the previous video, that is in the second video, we had started exercise 5.1 and solved some important examples. Now, I took the example, say, find all the points of discontinuity if any. Okay, if f of x is defined as mod x plus 3 if x is less than or equal to minus 3, minus 2x if x is lying between minus 3 to 3, and it attains the function 6x plus 2 if x is greater than or equal to 3. Here you might have noticed in the previous example there were only two functions, so there was only one point which may be a break or a joint. But here I have three functions, means for mod x plus 3 the line may be like this, maybe I'm not sure, and after that 2x may go like this, and again for 6x plus 2 it may be like this. If it happens like this, then these three functions are joining at these 2 points, then overall that function will be a continuous function. But sometimes what happens, the curve may break at x equal to minus 3 or x equal to 3. At that time, we'll be having for one line like this, for another one, for minus 2x, I may be having like this, and for 6x plus 2, I might have the curve like this. Okay, if it in case if the graph happens like this, then minus 3 and 3 are the points of discontinuity. Still we don't know what are the points of discontinuity. Okay, now we have to find out the discontinuity of the points of discontinuity if any for the following function, means it at each and every point I have to check what is the nature of this function. Now you look at mod x plus 3, you know modulus function is a continuous function. Plus 3 means 3 is a constant. Every constant function is continuous. Therefore, mod x plus 3, sum of two continuous functions is continuous. Hence, I can say mod x plus 3 is continuous for all x less than 3, only strictly less than 3. Up to x approaches minus 3, mod x plus 3 is a continuous line like this. Then we have minus 2x if x is lying between minus 3 to 3. Minus 2x is a linear polynomial. We know every linear function is continuous because every polynomial is continuous. Linear function is a polynomial of degree 1, means minus 2x is a linear function. Since every polynomial function is continuous, I can say minus 2x is continuous in its domain. What is the domain for this? It is lying between 6x minus 3 to 3. Then if it exceeds 3, if it becomes greater than 3, we have the function as 6x plus 2. Once again, I have 6x plus 2 is a linear expression. And we know every polynomial is continuous, means linear function is also polynomial. Hence 6x plus 2 is also continuous for all x greater than 3. But these three functions may have a join or a break at 2 points. One point is at x equal to minus 3 and another point is at x equal to 3. Okay. Now, let me find the continuity at x is equal to minus 3. At x is equal to minus 3. So, as usual, I define left-hand limits. Limit of f of x as x tends to a minus h. What is our a here? Minus 3. So, as x tends to minus 3 minus h. When I put under the mod minus 3 minus h, under the mod minus 3 minus h, modulus of minus 3 minus h means modulus of minus 3 is equal to, we have plus 3. 3 plus 3, it will be 6. So left hand limit is 6. Similarly for right hand limit. Right hand limit is x tending to a plus h, minus 3 plus h. When x exceeds minus 3, that is minus 3 is less than x, means what? X is greater than minus 3. The function is minus 2x. Minus 2x. Minus 2 as it is. X is replaced by minus 3 plus h. Then minus 2 into minus 3 means minus into minus, it becomes plus 6 I have. Similarly, the value of f at minus 3, that is what our limit as x tends to minus 3, f of x. Now you look at equal to sign. Equal to sign is there for mod x plus 3. So I have considered mod x plus 3. Directly substitute in place of x this value minus 3. Modulus of minus 3 plus 3. Modulus of negative number, we have positive. 3 plus 3, it is 6. Okay. There was a slight mistake while printing. Okay, it is done by me only. Modulus of minus 3, it will be 3 only. So hence it is 3 plus 3, it is 6. So left hand limit is equal to right hand limit is equal to value of f at minus 3 means it is continuous at x is equal to minus 3. Now, let me look at one more point, which is a break or a joint. Let us find the continuity at x is equal to 3. Left hand limit for x equal to 3. I define left hand limit as limit of f of x as x tends to a minus h. What is our a here? It is 3 minus h. When it is in the neighborhood of 3, what's the function? Now you look here. X is less than 3. X is less than 3 means for left hand limit, the function is minus 2x. So I wrote it as limit minus 2x as x tends to 3 minus h. Okay. Then minus 2 into, in place of x I put 3 minus h. This value is to be substituted in place of x. So I have minus 2 into 3 minus h. Minus 2 into 3 minus h means it is minus 6. Okay. Then I define right hand limit. What's the right hand limit? Limit f of x as x tends to a plus h. It is x tends to 3 plus h because we are finding the continuity at x equal to 3. 6x plus 2. What is our x? X should be replaced by 3 plus h. This x is replaced by this limit value 3 plus h. 6 into 3 plus h plus 2. 6 3s are 18. 18 plus h is negligibly small, you know, in the previous video. So 18 plus 2, it is 20. Right hand limit is 20. Now, the value of f at 3. Okay, it is limit of f of x as x tends to a, this as x tends to 3. Where is the equal to sign? Equal to sign for 3 is at the function 6x plus 2. So I have considered the function 6x plus 2. 6 into x is replaced by 3. So 6 into 3 plus 2, it is 20. So you will observe here, left hand limit is minus 6, right hand limit is 20. This means left hand limit is not equal to the right hand limit. Even the right hand limit is equal to f at 3, there is a break. Hence, f is discontinuous at x equal to 3. Overall, what I can say? Mod x plus 3 is continuous for all x less than minus 3. Minus 2x is continuous for all values of x lying between minus 3 to 3. And 6x plus 2 is continuous for all x greater than 3. And also just now we saw it is continuous at x equal to minus 3. But it is discontinuous at x is equal to 3. So x is equal to 3. X is equal to 3 is the only point of discontinuity in this example. Followed? I hope you have understood. Let me move on to the next question. Discuss the continuity of the function f where f is defined by. Here also our function is defined by 3 different functions and the interval is broken as x less than 0, x lying between 0 to 1 and x here it is 0 and x greater than 1. Here also f of x is 2x. 2x is a linear function. You know every polynomial function is continuous. Since linear function is also polynomial of degree 1, I can say f of x is 2x. F of x is 2x is a linear function. It is continuous for all values of x less than 0. And there is, after x is less than 0, if x is lying between 0 to 1, I have the constant function. It's attaining 0. Means every constant function is continuous. So our function is continuous when x is strictly lying between 0 to 1. Okay. When it exceeds 1, we have again 4x. 4x is a polynomial. It's also continuous in its domain. There's this for all x greater than 1. Then what are the points of, maybe the points of break or joint here? Here x equal to 0 is 1 point and x is equal to 1 is another point. Now let me find out the continuity at x is equal to 1. X is equal to 1 if I take, limit of f of x as x tends to 1 minus h. 1 minus h, that is, if x is less than 1, I have the function as constant function. It is 0. Then if the function is continuous, left hand limit value is 0. Now, right hand limit. Limit of f of x as x tends to 1 plus h. That's what our f of 1 plus h. This is another way of writing the continuity. Okay. Now, how is h? H is very small. When x exceeds 1, how is the function defined? It is defined as 4x. 4x. X is what here? 1 plus h. So 4 into 1 plus h. What is h? H is infinitesimal. It is 0. So 4. I have got. Left hand limit is 0 and right hand limit is 4, means left hand limit is not equal to right hand limit. Therefore, x equal to 1 is the point of discontinuity. Okay. And I have told you to check it for x equal to 0 also. What will be the left hand limit? Left hand limit is limit f of x, limit f of 0 minus h. When it is less than 0, what is the function? It is 2x. 2 into x is lesser, I write 0 minus h. So h is infinitesimal, means I get it as 0. And for right hand limit of f at 0, what happens? When it exceeds 0, I have the function as constant function. It is 0 because they have given it. Hence, left hand limit is equal to right hand limit is equal to value of f at 0. Hence, the given function is continuous at x equal to 0 also. It is continuous at x is equal to 0 also. Then, the only point of discontinuity is at x is equal to 1. Okay, I hope you understood. Now, I have considered this particular sub question as the 4-mark questions itself because in your annual examination, only one question on continuous functions will be asked. That too 4 marks question. It will be in the part E section. In part E section, you will be having 2 10-mark questions. You have to choose any one to solve with the exam. Okay, and in that 10-mark question, it will be broken as 6 plus 4. One 6 marks question plus 4 marks. In a 6 marks question, sometimes a question on the properties of definite integrals will be asked. Along with that, one 4 marks continuity. And one more, in the another one is 6 marks LPP question will be there. Linear programming problem. That we are going to see in the next chapter. Linear programming problem, 6 marks one question. And the next question, maybe this continuous functions or the question on the determinants. So this is important for only 4 marks in your main examination. But as per your knowledge is concerned, as for CET questions, in CET also, minimum 2 to 3 questions will be based on the knowledge of continuity only. Okay, like what is the domain and range for continuous functions? Is the tan x continuous? Like that. Okay, we shall see the 4-mark questions in the next video. Okay, kindly go through the videos. Thank you.